In this video, we are going to solve a question based on dynamics, and this question goes like this. Two objects are connected by means of an extensible massless string as shown in the figure below. The surface is rough and has a coefficient of kinetic friction which is mu k. The poly is frictionless and M1 is greater than M2. So they're saying draw a free body diagram of each of the objects. B, they're saying show that the acceleration A is equal to m1g open bracket sine theta minus mu k cos theta close minus uk m2g over m1 plus m2. Then C, they're saying find the acceleration and the tension in the string if m1 is equal to 6 kgs, m2 is equal to 4 kgs, theta is given by that, and coefficient of kinetic friction is given as 0.2. So the figure we're talking about is this one. This is the figure they're talking about. So you have the freedom to pause the video, try to solve the question, then get back to the video and try to refer to whatever we're going to solve here. Okay, so from this diagram which is here, we can draw a free body, or we can draw free body diagrams for these two objects and be able to find the acceleration, or be able to show the acceleration. Two diagrams for you to easily understand, to say the direction of acceleration is going to face or is going to point in this given path. You have to make sure that you look at which object here has a bigger mass. So since we are saying this has a greater mass than this one, meaning that acceleration is going to point in this given direction for M1, and for M2 acceleration is going to point in this given direction. So meaning that here the only thing which is going to make this one move has to be the tension. Here the one which is going to make this one move has to be the component we are going to get for this one once we draw the free body diagram.
Fwedede olontile das ya stansi banduka mune olontile Fwedede New dance pass street in it Fwedede Bounce kuli beating Fwedede Bude pili buka tolo mekono lukungu Tesh momo dance in it Ati dance ishupile paseti Fwedede Dance iliko sega feti
Now for the one which is on the incline, this surface which is the incline has to be your x, meaning that the forces in this x-axis, they give us acceleration. So I would say the summation of forces in x must be equal to what? Acceleration. And also here the summation of forces in x must give us acceleration. But the forces in y, they don't give us acceleration because the object, or rather the objects, are not accelerating at all. So I would say the summation of forces in x must be equal to ma for both of these two objects. But summation of forces in y must give us 0 because these two objects, they're not moving in y-axis. All right, we proceed. Now, trying to focus on this one, remember the question is trying to ask us to say we need to first, this one has to be our question A. We are done with the free body diagrams. We come to this one now where we are trying to show that acceleration is given by this. All right, so for us to show that acceleration is equal to that one, we are going to do this with the help of two different things. I'll start with this one. Remember, the tension is the one which makes it move in that given direction. Then I'll say T minus the one which is opposing. Why am I saying minus? Because this one is trying to oppose. Always, any force which opposes the motion, it has to be having an opposite acceleration. So we're going to say friction, it must be equal to M2 M. At this moment of time, friction force for this one, we understand that friction is going to be equal to mu normal. Here the normal force has to be equal to what? Mg, or rather the weight, because these two, they balance. The object is not moving in y-axis. Same applies to this one. The normal force must be equal to the downward force which is going to face in this given direction. Meaning that for this one, where there is normal, I'll say friction for the second mass, I'll put it as mu. I'll say normal force here has to be equal to M2G. So since I'm trying to start with this one, that's what I'll put where there is friction force. Okay, so I'll say T minus mu M2G, it has to be equal to M2A, and this qualifies to be our first equation. Then we try to come to the second equation. This one is the only force which makes it move in this given direction. The component in this case, which is M1 G sine theta. Then these two, they are opposing. So I'll do like this. Then I'll say M1 G sine theta minus friction, which is opposing, minus tension again, which is opposing. It has to be equal to the acceleration of the same mass, which is M1. I'll say M1A. But again, for friction force, you have to be very, very careful how to come about with the same friction force. So you are going to understand that for you to come up with the friction force, here you say friction has to be equal to mu normal. So what is this normal force? And this mu has to be K for both of these. It has to be K. Even here, it must be K, because that is coefficient of kinetic friction. All right, so you understand it fully to say normal force here on this object, it has to be equal to that one, because the object is just sliding on the surface without sinking into the surface of that same incline. So we are going to have normal force, which is going to be, this normal force has to be equal to M1 G cos theta. So to find the friction force for this one, it has to be equal to mu. Normal has to be equal to that. We are going to say M1 G cos theta. That's what I'll take and replace where there is friction force for this one. Okay, so we are going to write it like this: M1 G sine theta minus the friction force we are from getting there. Okay, cos theta. Sorry. Mu K M1 G cos theta minus tension. This has to be equal to M1A, and this qualifies to be our second equation. Okay, now I'll say solve 1 and 2 simultaneously. I'll combine this equation and that equation, solve them simultaneously. Okay, so to solve them simultaneously, I'll just say T minus mu K M2 G, it has to be equal to M2 A. Remember, these two objects, they're going to have the same tension and the same acceleration. That's why we don't have M2 and then A2 here, or maybe for this one M1 A2. No, they're connected with the same string. They also have the same acceleration. So this one is going to be M1 G sine theta, same minus mu K, then M1 G cos theta minus tension. This has to be equal to M1A. Then I'll just do like this. I'll say I'll add. So trying to add, you add what is on your left hand side and also what is on your right hand side. You understand to say this and that can just go, because this one is having positive and finally this one is having minus. So I'll start with the one which is positive. I'll say M1 G sine theta, and I'll come here, I'll say minus mu K M1 G cos theta minus mu K M2 G. I'll equate these two. If I add these two, I'll just factor out acceleration. I'll write it like this. Now add the masses M1 plus M2. I'll close them like that. Now try to write this in a proper way. I'll start with this. I'll say A open M1 plus M2 equal to I'll write this one now. M1 G sine theta minus mu K M1 G cos theta minus mu K M2 G. Now to find the solution to show that acceleration is equal to like this, we can just do it in a simple way by dividing first of all throughout by M1 plus M2. So we are going to have M1 plus M2, M1 plus M2. I'll cancel this. My acceleration has to be equal to, here I'll factor out what is common. What is common at this moment of time? M1 G is common. I'll say sine theta minus mu. So I'm trying to factor out mg for M1 G for this one, meaning that here we're going to remain with mu K, that is cos theta. I'll close minus mu K M2 G. I'll divide this by M1 plus M2. If we get back to the question, you'll find that what is here is what we're from getting. Then we just conclude by saying hence shown. Okay, now the thing is we need to find the last question whereby they want us to find the acceleration as well as the tension. So it will be very simple for you to find the acceleration and tension because the masses have already been given including this one. So I'll just replace in this one and also just get whichever equation which is either this one or the last one, but the best is to choose this one because here you might end up getting confused. So if you pick this equation, you need to be so attentive, but we're going to get the same answers. So I'll use this one to find tension, and I'll use this one to find acceleration of these two objects. Okay, so I'll try to rewrite the formula here. Say A, which is equal to M1 G sine theta mu K cos theta plus mu K M2 G over M1 plus M2. So the data that we've been given, they're saying theta is given as 30 degrees, M1 has been given as 6 kgs, M2 has been given as 4 kgs, and coefficient of kinetic friction has been given as 0.2. Wow, the question has been simplified now. So the reason why we are saying the question has been simplified is because I'll get these values and plug them here to find the acceleration. So we're going to have A, which is going to be equal to M1 6 multiplied by 9.8 open sine 30 minus 0.2 cos 30 close minus 0.2 multiplied by 4, which is M2 multiplied by 9.8. Now say over 6 plus 4. So acceleration, if you do calculations, you are going to get something like this. I'll punch one by one. I'll start with the ones that are inside the brackets. So I'll say sine 30 minus 0.2 cos 30. What answer are we getting? So I'll say 6 multiplied by 9.8. I'll multiply everything by 0.3268 like this minus 0.2 multiplied by 4 multiplied by 9.8. Okay, say over 10. Yes, so if we try to multiply, what we are going to get here, if you say 6 multiplied by 9.8 multiplied by 0.3268, what answer are you getting? Acceleration is going to be equal to, so here we are getting 19.21584 minus, what answer are we going to get if we multiply that side? 0.2 multiplied by 4 multiplied by 9.8. So I'll write this one minus that. say 19.21584 minus the answer. So I'll divide this by 10. What answer are we going to get? Okay, let me just cancel this. I'll say acceleration has to be, so we are getting our acceleration as 1.14 meters per second square. All right, so we get back a bit to this formula. I want to find what we call the tension now. All right, to find the tension, I'll just pick this equation and write it down here. Say T, it has to be minus mu K M2 G, it has to be equal to M2A. Take this one to your right hand side. Tension is going to be equal to M2A plus mu K M2G. So tension is going to be equal to, I can factor out M2. I'll have something like this, mu K G. Tension is going to be equal to, okay, so we are going to have 4 open 1.14 plus 0.2 multiplied by 9.8, meaning that tension has to be equal to, right, calculator is there. So I'll start with this one, then I'll add with that. So I'll say 1, okay, let me do this, 0.2 multiplied by 9.8, I'll say plus 1.14, and now I'll multiply this by 4. What answer are we going to get? We are getting the tension to be 12.4 newtons. This is how you handle this question. Like our video, share with your friends so that they can also benefit. Try to subscribe to our channel for more videos. Thank you very much for watching once more.